Hi guys, welcome back to the new video on pointers. We are continuing our learning for C++ programming language. This is module 8 on pointers. Let us begin. Before I start, I'm really sorry about a huge delay in uploading this video. I couldn't upload it on time. I was not finding time to record the video because I was shifting my office to a new location. But as most of the things are settled down now, I think I'll be able to upload new videos regularly on time. So let us begin. So pointers is a very important topic in C++. We know that pointers are derived data type that referred to another data variable. Okay, so pointers we have seen in C language in detail. We are just going to revise pointers and we are going to see how pointers are used in C++. So again, pointers are by definition nothing but derived data types which refer to another data or a variable. Okay, and they do that by storing variables memory address location. Okay, they do not store data as such. So just to understand this concept here, assuming this is a memory location, assume that it has certain address over here and this memory is allocated to variable x. We have suppose initialized value as 10 and stored it into x. So 10 is here. Okay, so x has stored value 10 at address location this. So when I say a pointer, so pointer is another variable which basically points to this location. So what is location? So this is the location address. So this particular information is stored over here. Okay, so pointer variables, they do not store actual data, but they just store address location of another variable. So fairly simple concept to understand. Then the syntax of declaring a pointer variable is like this. So we have our data type, then star as the character symbol, then your pointer variable name. Okay, so for example, you can have your integer data type, then star p. Okay, so p is the pointer variable. Now that is denoted by star. So this is syntax for our integer pointer. Similarly, we can have a character pointer. We can use character data type, then star, and then your character pointer name. So let's say chp is my character pointer name. So we are going to take one example how the pointers can be work when you have multiple variables and then a pointer variables pointing to those certain variables. So in this example, we have one integer pointer, that is a, and then a normal variable b of type integer. So I'm initializing b with value 10. Okay, so what is happening here is we have a variable, a certain memory is allocated to it. Let us say ox1 is the memory location for variable b, and then we are initializing value of b with 10. Then on the next line I'm printing address of b. So this is just a string that will be printed, and then I am saying address of b ampersand b. So this line is going to print this information, and then on the next line we are printing value of b. We are simply providing b. So on the next line b will be printed with this string, so value of b inside bracket b colon, then value of b, that is 10. And then I'm initializing my pointer variable over here with address of variable b. So variable a will be pointing to address of b. So ox1 will be stored over here. So after this line, what I'm doing is I'm printing address of b in pointer a, and then I'm simply writing a. So this information will be printed, and then in the next line I'm writing content of b in pointer variable a, that is star a. Now I have given this trick multiple times in our C programming language series as well. To understand star a, we can just simply replace it with star ampersand b. Why b? Because of this particular statement, because a is pointing to address location of b. Now to read this value, we just simply replace star with keyword value. So value at address of b. So this is our address of B, and what is value over here? That is 10. So star A is going to print 10. Okay, so this line will print value of B using your pointer variable A. Then on the next line, I am reinitializing B with 20. So this particular line is going to print address of B in pointer A colon A. This is again going to print this value. And then on the next line, we are again printing star A. So that is nothing but value at address of B, so which is updated value, that is 20. Now another way to update value of B is by using your pointer variable. Okay, so star A equal to 30. So this is nothing but writing value at the address location of B equal to 30. So this value will be updated to 30. So we have seen initially the value of B was 10, then we re-updated it to 20, and then using your pointer variable we re-updated it to 30. After that, this line is again going to print address location of B, and when we just simply print B, it will print 30. Reason is that the value of B was updated by variable A. So this will be the output of this program. So this was output that we compiled on a local computer, and this was the address location of variable B. So this was initial value of variable B, that is 10. Then it got re-updated by this statement, so it printed us 20, and then using pointer variable we re-updated the value and it got re-updated to 30. And wherever we had printed address location of B, that was unchanged throughout the program, because we technically did not change or did not touch anything related to the address of B. Now we can perform arithmetic operations as well using pointers. For that, what I am doing here is I have created one integer array of size 5, and I have set initial values to all those array locations. So these are integer values that will be stored into arrays 0th location, 1st location, 2nd, 3rd and 4th location. And then we have one integer pointer here, which we will be using to point to our array, and then a variable sum will be used to add up all these numbers and store output into variable sum. So on the next line, what I'm doing is I'm initializing, or I'm pointing my integer array to my pointer, which is of type int. So ptr is going to point to the first location of the array, so that is 0th location. So after that, I'm creating one for loop. So starting from 0 till 4, it will loop through, and at every iteration this is going to get executed. So in the first statement, we are printing address of variable I, so that is our index variable or the loop variable. So in the first iteration it is 0, so 0 will be printed over here, and then we are writing equal to ptr. So ptr, because it's a pointer and it is initially pointing to this first location, so it will display address of this particular array element. And on the next line, we are displaying value of variable I is equal to star ptr. So again, star ptr is nothing but your value at address location of this variable. Okay, so whatever the value is here, which is 10, so 10 will be printed. And once that happens, we are updating variable sum with sum equal to sum plus ptr. So in this particular iteration, value of ptr is 10, so 10 will be added into sum. So in the first iteration, 0 plus 10, that is 10, that will be stored into sum. And then last line is we are writing ptr plus plus. So this is very important line over here. So here what is going to happen, we are increasing pointer by 1. So wherever the pointer is pointing correctly, that pointing location will be incremented by 1. So pointer will start pointing to the next location in the array. So once these set of statements are executed, pointer will be incremented by 1, and in the second iteration, value of I will be incremented because of this statement I plus plus. So I will become 1, and then in the next iteration, address value of new variable I. So address of your pointer variable, that is for the first index, will be printed here, and then the actual value which is stored at that particular location will be printed, and again your sum will be updated. So in the second iteration, what is going to happen? 10 plus 20. So 20 is your current value where your pointer is pointing, and sum was your previous value which was updated after end of your first iteration. So sum will become 10 plus 20, that is 30, and again pointer will be incremented, so it will point to this location. So similarly, your these variables will get added into variable sum. In the final iteration, when your I becomes 4, this is going to happen. So let us assume that 10 plus 20 plus 30 plus 40 has happened now. So this addition was stored into variable sum. So new value, that is 50, will be added into existing value of sum, that is 100. So 100 plus 50, so it is 150. So sum will be finally updated to 150, and again your pointer will be incremented. But now what is going to happen, that we have already ended the added limit over here. So it doesn't matter where the pointer is going to point next. So obviously pointer is going to point to some garbage location which could be irrelevant for us, and the program will terminate because value of I will be incremented from 4 to 5, and this condition will be false. So next iteration will not be executed, so that will effectively end your for loop, and this line will be executed. So cout is going to print sum of array is equal to 150. So in this program, what we have done is, using pointer variable, we have traversed through all the array elements of one integer array. So this is how we can perform arithmetic operations using your pointer variables. So this is going to be the output of the program. So program has printed all the addresses of your array elements and value which are stored at those address locations, and in the end it has printed the sum as well. Now in the next slide we are going to talk about array of pointers. Okay, like we have array of variables, we can also have arrays of pointer variables. So this is one integer array, and then we have one integer pointer array. Okay, so like we have 5 variables over here which are basically combined into one array, we can have 5 pointers which are combined into array. So what we are doing here is, we are using these pointer variables to point to all these normal variables or normal integer variables, and each pointer is going to point to this address locations. Okay, so in the memory what is happening, we have these 5 array elements. So let's say 10, 20, 30, 40 and 50, and then we have integer pointers as well. So these are 5 integer pointers, each of that is going to point to these address locations like this. But this doesn't happen automatically, so for that we are using this for loop. So my for loop is going to iterate from 0 to 4, and then one by one each pointer variable will start pointing to my integer which is part of your array. So in the first iteration, my 0th location pointer variable will start pointing here, and similarly other variables, other pointer variables will start pointing to the other variables. So once this pointing is done, in the next loop we are going to just reprint all these values which are 10, 20, 30, 40 and 50 using our pointer variable. So this is my for loop starting from 0 to 4, so 5 address locations, and we're just printing value of integer array. Here I'm passing integer I, which is going to display index value of my array, then equal to, on the next line I am writing star ptr I. So what is technically happening over here? In the first iteration, I'm writing star ptr I. So this is my ptr, okay, and this is my integer array, okay. So I'm writing address location of integer array 0, okay. So value at the address of integer array 0, which is 10 for the 0th iteration. So that will be printed. Similarly, in the second iteration, where I becomes 1, 20 will be printed, and so on. In the last iteration, 50 will be printed. So this is the output of this program, okay. So these are your normal integer array, okay. These are your index x, and all these values are printed using array of pointers. Now we are going to touch upon strings, okay. So strings are nothing but your character arrays, okay. So if you check this particular string Kodegod, so it is nothing but character set of 7 characters, and as we know that every string ends with 1/0, which basically denotes compiler that this is end of the particular string. So this is nothing but 7 plus 1, that is equal to 8. So this particular string str is of size 8, and then we have one character pointer variable, that is star ptr. So I'm just going to write ptr is equal to str. So when you write a string array variable without square brackets, so this denotes address location of the first character variable, that is this value. So that I'm assigning to my pointer variable. So because of this statement, your pointer variable ptr has started pointing to this first location, okay. So ptr is pointing to the first character location of string str, okay. Now once this pointing is done, using variable ptr we can print this string as is. So while printing this string we can simply write ptr. So because ptr now denotes this address location, so we can write ptr and it will print value of string in variable ptr is this value. So because it is pointing this particular location, it will start printing Kodegod till the compiler reaches /0. So once /0 is reached, it will, for compiler it is end of the string, so it will stop printing there, but it will print Kodegod completely. Now in the next line what I'm doing is using the for loop and using the standard notation that we have seen in the previous video, that is star ptr. We can still use the traditional method, and along with star ptr plus plus we can increment each location using your for loop, and we can still print one character at a time, okay. So using for loop, using this particular for loop, which is going to iterate through 0 to 7, it will print output like this. So because of this particular statement, the compiler is going to print this particular line, and it is going to print Kodegod as complete string, and then using for loop these values will be printed one by one as a character. So fairly simple concept to understand, and in the next slide we are going to talk about pointers to objects. So like a pointer variable can point to a normal variable, we can also have a pointer to object which can technically point to another object. We can have a class pointer which can point to object of a class. So in this example we have a class, I'm calling this class as math, then we have private scope, and then 3 variables a, b, c, all of them are of type integer, and then in the public section we have one function math, which is your constructor. If you check, the class name is same as the function name, so this is your constructor, and it is default constructor which has these initialized values, or it is a parameterized constructor to which we have passed these values, and those values are stored into your data members a, b and c, and then we have one more member function as addition, which is just going to simply return addition of variable a, b and c. And then in the main function I have created two objects, m1 and m2, and to which I have passed these values. So these values will be overwritten with this set because I'm explicitly sending those values. So these initial values 10, 20 and 30 will not be used actually, because I'm explicitly sending fresh set of values when I'm creating this object m1. And then we have one class pointer. So star ptr math is a pointer to object. Then what I'm doing is I'm pointing ptr math, which is my pointer to object, and I'm referring address location of my first object m1. Okay, so inside of memory, when m1 is created, okay, let us assume that abc for object m1 have got these consecutive spaces, and we have, because initialized values 30, 12 and 15 to these address locations, and because of this statement I have created one pointer which is going to point to my m1. Now once that pointing is done, using my pointer variable I can access these data members. Also I can access my member functions too. So we can use array operator over here. So using the pointer variable I'm calling my member function directly. Okay, so this statement is similar to writing m1 dot addition. Okay, so output of this statement and this statement is same. Only thing is that we are using pointers here to call my member function. Then what I'm doing is for m2 object, where these set of values were created initially 5, 60 and 20, so I'm changing pointing of my pointer object from here to here. So this will be broken and new pointing will be created over here. So when I'm writing ptr math along with array operator and then addition, so addition function will be called over here, but this time it will be referring to these values. Okay, because m2 has a different set, m1 has its own different set. So depending on choice that we make and where the pointer variable is currently pointing, those set of values will be accessed. Okay, I think it's fairly easy to understand this concept. So let's move on to the next slide. So this will be the output of this program. So 57 is outcome of addition of variables from m1 object, and 85 is the output of addition from my variables in m2. Now one very important uh, pointer that C++ has, it's this pointer. So why there's a need of this pointer? Okay, so whenever a data member is called, so sometimes there could be a case wherein we need to understand that which particular object I'm referring to. Okay, so my program can have multiple objects. Okay, and for a class, when a data function is called, okay, so when compiler loses its scope, let's say compiler is now executing some code from the class. Okay, so this particular function can be called from other objects too. So while we are executing these lines, it's good to know that which particular object we are dealing with currently. So in that case, because each object could be having different names like m2, m3 and m4, we cannot refer those over here. Okay, that is why to refer to your existing object, this pointer can be used. So this pointer is a keyword. So this is the keyword which basically points directly to the called object. Okay, as in the object which is calling your function, this object will be automatically pointing to that object. Okay, so let us try to understand this by with the help of one example. So again, I have class math, then we have two private variable a and b, and inside public section, we have math as the constructor, wherein we have few default values x equal to 15 and y equal to 20, and which are being assigned to variable a and b, which are again the private members. And then we have one function addition, wherein we are adding two values and returning total of those two variables. And then we have another method compare, to which we are passing object math. So when this particular object is passed, inside of this function I'm referring this arrow operator addition. So whenever I'm going to make this call, the object which is calling this method, data members of that particular object will be used for executing this particular function. Okay, so inside this particular function, what is happening, using this operator, I'm using object which has called this particular function, and then I'm comparing whatever the value that this function is returning me with my fixed object which I'm passing here. Okay, so this addition function is going to return me addition of two different objects. Okay, so let us try to understand this by our main function. So we have two objects m1 and m2, to which I'm passing values 560, 30 and 12 respectively. So in the memory, what is going to happen is, so this is my m1, to which 5 and 60 is initialized for a and b, and then m2, again here a and b is initialized with 30 and 12. Okay, this 30 and 12 will be passed to the constructor, and constructor will initialize value of a and b. So this is something that is going to happen. And then interesting part, inside of if, I'm writing m1 dot compare. So this particular function will be called, but notice that I'm calling compare function using m1 operator. So when here we send this, so technically we are calling m1 dot addition. Okay, so because compare function was called by m1, hence this is pointing to m1. So m1 dot addition is performed here. So this particular function call is going to return me addition of 5 and 60, that is 65, and 65 will be compared with math. So inside this particular statement, I am passing m2 as well. So m2 is passed over here as a copy. So we are going to compare it with m2 dot addition. Okay, so this particular function here is going to return me addition of 30 and 12. So that is nothing but 42. So we have the results here. So 65 greater than 42, which is a true condition. So true will be returned over here. So if true, which is a true, so C out m1 is greater than m2 will be printed, and this particular code block will be skipped. So output of this program is m1 is greater than m2. So important concept that we have learned over here is about this pointer. So this pointer is fairly commonly used across object-oriented programming. So this concept is almost similar everywhere. Then finally in the video we have one important topic, that is virtual functions. So when we use same function name in both base class and derived class, then the function in base class is declared as virtual. So we have seen in inheritance there could be cases wherein we may require certain functions to be inherited, but your base class need not have certain definition. So in a way, when you have some base class, you can just have certain declarations done, but once the inheritance is done, you can have your definitions inside your derived classes. Okay, but let's try to understand this with one example. Before that, we just let us check how the syntax can be implemented for virtual functions. So keyword virtual is used just before your function declaration or definitions. So virtual, then you return data type, then your function name, and then your list of parameters. So here is one example on virtual functions. So class parent is my base class. So here I'm adding keyword virtual, just notice that, and then I'm writing this is the base class. Then we have child, which is inheriting my parent. So inside of my class definition of class child, I have similar function name, that is show. Notice we have not write virtual over here, and I'm writing this is the derived class. So parent star p, I'm creating one pointer variable for my class parent, and then a normal object for class child. Then I'm writing p is equal to address of c. So what is happening over here is I'm creating one pointer variable which is pointing to object of my derived class. So once this pointing is done, using arrow operator, I can call show method. But because this pointer variable is pointing to my object of derived class, so this particular function is called. Okay, so output of this program is this is derived class because this particular code is called here. Okay, now again let us try to understand this with one more concept, that is about pure virtual functions. So as I explained in the first slide related to virtual functions, there could be cases wherein you can implement your base classes, but certain functions need not have definitions inside your base classes. So in such cases, what you can do is write pure virtual functions which technically do not have any definitions, but they can have certain declarations. Okay, and that can be denoted something like this, equal to 0 semicolon. So pure virtual functions are usually called as do nothing functions as well. So they do not have any definitions inside of your base classes. So here is one example for the same. So this is class shape, and inside of public section we have our virtual function which is returning variable of type float, and then this is your function name calculate area, to which one float variable is passed, and because of this equal to 0 we can say that it's a pure virtual function. Then we have class square, which is a derived class, and we are inheriting shape over here as the class, and we are writing definition for our function calculate area. Okay, so this is the definition. And then we have another class, that is circle. So here we are inheriting shape as a class again, and we are redefining the same function calculate area. Okay, so just to denote here, so shape is my base class and it is being inherited into two more classes. One is square and other one is circle. So your base class was carrying this pure virtual function, okay, and those have been redefined into these two classes. So when I'm creating object for both my derived classes, so when I make a call using their respective objects, their respective functions will be called. Okay, so when I say s, which is object of square, that is s dot calculate area 6, so this function will be called. So it will do 6 multiplied by 6, it will return me 36 for this statement. So it will print area of square is equal to 36, and then on the next line I'm writing c dot calculate area and then 7. So c is object of class circle, so c dot calculate area. So this function is basically referring here. So this code will be executed. So this will calculate 3.14 multiplied by 7 multiplied by 7. So whatever that calculation is, it will be returned over here and it will print area of circle and then the output. So output of this program is this. So that was all on pure virtual functions. This was a relatively longer video, but I guess you have understood the concept. If you like this video, give this video a thumbs up. Don't forget to share this video with all your friends. You can support our channel on Patreon. I have added those links in the description. Just share this video, guys. It will really encourage us. So I'll see you in the next video. Enjoy.